All right. So we're gonna learn to factor. Do you guys know why we factor? Nope. Any idea? Oh, you don't even know what factoring is? Nope. All right. Well, so what if I gave you a problem like this and I told you to graph it, right? Or even I set it equal to 0. Oh, there we go. Board's not quite calibrated. And I asked you to solve it. What does that mean to you?
You have to move the -15 to the other side.
No. That's okay. You haven't really learned this. So I'm going to phrase it to you in another way. And this is basically why we factor. So have you guys ever felt like at the end of the year when you have all of your finals going on, you have like 10 things to do, that it's too much, right? And then what do? You try to take things apart, right? And you know, okay, well first I'm going to study for math, and then I'm going to study for science, and all of a sudden it becomes more manageable, right? Well, that's what factoring is. So you have a complicated problem like this, and you're not really sure where to start or what to do. That's why we factor. Because ultimately, like in Algebra 2, you guys are going to learn to do a lot of interesting things. Interesting to me, but maybe not to you guys. But you're going to learn to do a lot of things with these types of problems. But until you can break it down to its parts, it's really just a mess of like variables and exponents, all right? So when we learn, and if you were to graph it, that's what it looks like. So you're not going to do that this year, though. But next year, when you guys get to Algebra 2, you're going to start doing problems like this. But before you can do a problem like that, you have to learn factoring.
If I take Algebra 2, I'm going to be a teacher. Because I cannot do Algebra 2 with you.
No, it'll probably be me.
Oh my god, was that recorded? Take out the sound.
It's fine. So if I were to ask you, what is a GCF? What do you guys know?
Greatest common factor.
Greatest common factor, right? So you guys learned about GCF in middle school, right? If I asked you for like, if I give you numbers, and I ask you about the GCF, this is where we start with the learning of GCF, right? You guys can do this. All right, so now we're going to throw some variables into the mix. So this is the definition of a GCF for our purposes, all right? A monomial with an integer coefficient that divides evenly into each term. All right, so now I'm going to give you a problem like this, 12x, 42y. Before you guys took out the GCF, it was just numbers. All right, now we're looking at numbers and variables. But the first thing you want to do is always look at your coefficient. You guys remember what coefficient means?
Yeah.
So 12 and 42, is there a number that goes into both of those?
6.
Yep. Good, I'm glad you started with 6. A lot of students start with 2, which is fine. 2 goes into both of them, but is there a bigger number? 6. Is there a bigger number than 6? No. Now look at your variables. Is there a common variable?
No.
Not in this one. So what I can do is take out a 6. What's left when I divide a 6 out?
7?
Well, let's start with our first term. 2 and an x, right? Because I didn't take the x out. Now plus, right? And what's left in my second term? 7.
Okay. There's your answer.
And you factored it. Easy?
It's not that hard.
It's not that hard. It gets harder. It gets harder. All right, so let's do this one. All right, so if I were to look at my first term and my second term, what about my coefficients? What do they have in common? Okay, so I can take the 4 out. Now my first term has x to the 4th, which is really 4 x's. My second term has x cubed, which is 3. So how many do they have in common?
7. Oh.
Out of each one. 3. Yeah, so I could take out an x cubed. So remember, this is division. If I divide out a 4x cubed from 4x to the 4th, what do I have left? So 4 divided by 4 is 1. Okay, but what's x to the 4th divided by x cubed? Remember we just covered that lesson? What's left? If I had 4 and I took 3 out?
1.
Yeah, so I have x.
That's it.
Second term. What do I have left? 6. And
X.
I took out all...
Oh, no, nothing.
Yeah, I took out all the x's. So now that's been factored. Cool? So easy so far?
Yeah.
So this will be the first thing that you guys do. Actually, it's not the first thing, but it's right down here, right? No, we'll get there. That'll probably be, for the rest of our time, we'll probably be able to finish that worksheet. All right, so the next thing that you're going to learn, and this is actually, I went out of order in the homework, but it's solving. All right, so this is an expression. Why is it an expression? Do you guys know?
No equal sign.
Ah, yay. No equal sign. All right, but now I put an equal sign in it. So now you have to do 2 things. First, you have to factor, and then you have to solve. All right, so if we were going to actually take a minute and do this one yourself. Factor yourself, then we'll talk about how to solve it. Randy, you probably already know, but Issa, you were absent that day.
The GCF is 2, right?
2 and what?
X.
2x. Your GCF is 2x. Two and what? There you go. So that still has, oh, perfect, now it's right. Okay. So when you take out your 2x, right, you have x plus 4 equals 0. So this is a zero product rule. All right, what that means is that I have two factors, right? 2x times x plus 4. What I can do is take one of my factors, set it equal to 0, okay, and then solve. Take my other factor, set that one equal to 0, and solve. You have to do it for both. You may have 3 factors or 4 factors. That's algebra 2, but here we'll start with just 2. So I should have 2 answers. X equals what?
This one?
0. What about this one? Yeah. And these are both answers when I ask you to solve. Right? If I plug in a 0, it will equal 0. If I plug in a negative 4, right, and I do all the calculations, it comes out to 0. All right? So I made B a little bit different. I put my terms on different sides of the equal sign. But in order to use the zero product property, it has to equal what?
0.
It has to equal 0. So what do I do?
That's 0.
How do I move it?
Negative.
Fantastic. So now take a second and factor it again and then solve it. I'll give you guys a couple minutes to do that. So 3 and what though?
3 and 2.
Yeah. So Isa, what's left? When I pull out my 3n.
This is a fraction.
Oh, your answer ultimately? Yeah, it might be. So what do I have left when I pull out my 3n?
There's 2 and minus 15. Minus 5.
Okay.
I will find out.
You wrote 5? Row 5 instead of 15? That's okay. Alright. So over here n equals, yep, that's easy. And here you have to do a little bit more work, but in the end you get, yeah, 5 over 2, right? Add 5? Alright, which is okay. You can have fraction answers. Eventually you can have very strange and unusual looking answers, so this is fine. Okay? Alright, so now the next thing is factor by grouping. So before, like everything that we took out here, we took out a monomial, right? One term. Right. It's possible to take out binomials as well, but it looks a little bit more complicated. So if this was the problem, so I underlined it so you can see clearly the two different terms, but this could be a problem that I give you, and I ask you to factor it. Now, I'll probably never give you anything like this. I'll give you something that's on the next page. But I just want you guys to see, if you look at your terms separated by a minus sign, do they have anything in common?
4.
You're getting there. Look in the parentheses. That is actually an entire term. So what I would say is, if I'm looking at my first term, this, x plus 4, and if I look at my second term, this x plus 4 can actually be factored out. So if I divide by an x plus 4, right? What's left here? 2x. What's my sign? And then, there you go. Then you've now factored it. It just looks complicated because there's more going on inside, right?
Yeah.
Taking out, instead of just that little thing, you're taking out something bigger. Right, so it gets,
to do what?
that's it. That's actually factored. So, but I'll never give you a problem like this. Actually, you're going to have to figure out how to make it look like that. So we'll start here. So factor by grouping. All right, this is how you factor polynomials with 4 terms or more. You can factor polynomials with 4 terms, 5 terms, 6 terms, 10 terms. You guys probably won't see anything like that. But 4 terms you will. So what you do is first you want to group them. You want to ask yourself if you see anything in common. Look at the first two terms, and this one I set up nicely for you. But look at your first two terms. Do they have anything in common?
Two X's.
Mm-hmm. And what about your last two terms?
A 3. That's divided by 3.
But what do they have in common? What can you take out?
Oh, 5.
Yeah. All right. So what I'm going to do is I'm going to group them. And so I usually underline it just to help me clarify the difference between my first two and my last term, too. Now I want you to factor out the first two. No, because it's not 2x, it's x to the, yeah, there you go. Yeah, so now factor out, yep, next one.
If I take out 2, then this one is more X.
That's okay, doesn't have to. No, right, that's right. So now go to the next two. So what will you pull out here?
I pull out a 5.
Ah, perfect. Now keep in mind that there is a sign in front of that 5, based on what I wrote. What's the sign in front of that 5? Ah. So what do you notice inside the parentheses? Inside the parentheses you have what? The same thing. So if this is factorable by grouping, what you'll notice is, inside your parentheses, it's the exact same thing. If it's not the exact same thing, it's a couple of things. Either maybe you factored it wrong, number one, or maybe it can be factored by grouping. All right, so those are the two things you should think of. But anyways, now if we look at our two terms, and I'll underline them so you can see clearly, I have right here, that's one term, and that's one term. You guys already noticed that they have an x plus 3 in common.
Mm-hmm.
So I'm going to pull that out. So when I pull out an x plus 3, what's left over? What's left over here?
X.
Yeah. Oops, there we go. And, I think you said it, but, and plus 5. And now it's been factored.
Oh, okay.
All right? And actually, this is the problem that I started at the very beginning. Remember I showed you that graph? So this is the first step. If I were to graph this problem, you guys don't have to worry about that now. But instead of looking at it like this, I try to break it down into like more manageable parts, which we do all the time in life, right? We do it in math too.
Is that as hard as it gets?
Is that as hard as it gets? Sadly, no. It's not as hard as it
What about
gets.
in this class?
In this class, yes. Next year when you guys get to Algebra 2,
It's going to be the easiest part of factoring.
yeah, it gets harder. So
I don't want to
it won't be so bad, I promise. All right, so I want you guys to try this one yourself. Now, what you're going to find out is if you group it just the way that I gave it to you, like 2 and 2, you're going to, like, look here, x cubed and -6. Do they have anything in common? No. So sometimes you're going to get a problem that actually can be factored, but it doesn't look like it can. But you might want to rearrange your terms. So try this
the
one.
6 with the 3.
Yeah, so just remember, anytime you move something, though, take the sign that's attached to it with it.
So how do you move that?
So for the first one, all you do is just put it in.
So what do you want to group with the x cubed? What do you want to put with the x
What?
cubed? You want to put the 2x with the x cubed?
Yeah.
All right.
Oh no, the 3x.
All right, so I'm going to start if I'm not going to finish it, because I want you to try this one yourself. So you want to move this. You want to group this with your x cubed.
Okay.
So it's negative, though, right?
Yeah.
So I'm just going to...
minus.
Yeah, so I'm going to take the sign with it. All right, so rearrange the rest of it. Group
So
2
that's
and 2.
one group. And
Yeah.
then -6
And
plus
these-
2x is a 9.
Mm-hmm.
Oh, you can do that?
Yeah, you can. As long as you keep the same sign, the sign that's in front of it, then you can do that.
This is correct.
So look inside your parentheses.
They're not the same.
They're not the same.
No,
All
for
right.
me they are.
So, oh, you know why? Because when you rearrange it, look at the problem and look at what you wrote.
Oh.
There. Now pull out something.
Are they,
Yes, but is it the same? Even if though it doesn't look the same, right? You could just flip
Wait,
it. Yeah.
yeah.
Okay.
Is that it?
But see what you did here is you forgot, you took out a plus.
Oh, I did it there.
Okay, you just didn't write it, but that's fine.
Yeah.
Oh, and you did it like this. Fantastic. So I like it. You guys actually did it two different ways. So I'm going to do it Issa's way and Miranda's way. Right? And in the end, you'll see it'll be the same thing. So Issa, you wrote it like that. Miranda, you did it like that. All right? So both of you took out x squared, right? And x minus 3,
Yes.
which is fine, which is great. Okay, so Miranda, you took out a what? A plus 2?
2.
Plus 2, all right? And try to remember, always write that sign because it'll tell you what to write in your parentheses. So what were you left with though?
Negative 3 plus 8.
And Issa, what did you take out over here?
2.
A plus 2? And you're left with that, right? That's what I saw? All right, is this the same or different?
Okay.
Yeah. And then even, so Miranda's looking at her parentheses and I told her that they always have to be the same. But in the end, isn't that the same? Okay. So the last step was, you guys did what? What did you factor out?
X is 3.
X, okay.
X is at the power plus 2.
Fantastic. So you both did it a different way and got the same answer, which is the right answer. Okay. So that's another wonderful thing about math, is sometimes you can solve a problem in different ways and still get the right answer. So you just have to be creative. But keep that in mind, especially as we get to farther sections in there, you may have to sometimes rearrange. All right? So I want to work on, so Miranda, you've done sum of 9-4?
Yeah.
Okay. So let's just start here and try to, oh, there's a little bit at the back. I don't know. We might get there. Let's just start and see how far we can get. And then we can do problems on the board maybe, if you have questions.
I'm not even going to homework. Why? If it's homework.
Oh, I did.
Which means that you have an extra day to do all your homework.
I did.
Maybe I should assign more homework. Because you have more days.
No.
But I started 9-4.
Alright. So I'll work on the answers for you guys.
That's not fair.
Yeah, but you were absent for so long.